Imagine flipping through a dusty old family photo album, the kind that's been passed down through generations, and then suddenly finding a picture of your great-great-grandparents, not as you'd expect them to be, young and starting out, but fully grown, seemingly out of time, in a photo dated before they were even born. An impossible image. That's the kind of cosmic mystery astronomers are grappling with right now, a puzzle that challenges our understanding of time itself. The James Webb Space Telescope, our most advanced eye on the universe, has peered into the deepest reaches of space and time and found something that simply doesn't fit our established story of the universe. An anomaly. It's a faint signal, a whisper from the dawn of time, so incredibly ancient that it's making us question everything we thought we knew about the very beginning of the cosmos, the moment of creation itself. This isn't just a minor detail, a slight adjustment to our models. It has the potential to shake the very foundations of cosmology, the science that seeks to explain the origin and evolution of everything. For decades, scientists have painstakingly built a timeline, a narrative of cosmic history, Big Bang, the initial explosion, a superheated soup of fundamental particles, the formation of the first atoms, hydrogen and helium, and then, finally, the birth of the first stars and galaxies. But this newly discovered object is like finding a skyscraper, a fully formed metropolis in a village of mud huts. It's far too advanced, too massive, too early. The implications are huge, sending ripples of excitement and uncertainty through the scientific community. Maybe the universe is far older than we thought, or perhaps it's stranger, filled with phenomena we haven't even begun to imagine. Or maybe, just maybe, the universe followed rules and pathways we never even conceived of. The excitement among scientists is electric, a palpable buzz of anticipation and intellectual curiosity. This is precisely the kind of groundbreaking discovery that forces us to fundamentally rethink everything we thought we knew about the cosmos. This single faint point of light captured by the Webb telescope after traveling for billions of years is a humbling and awe-inspiring reminder that the cosmos is far more vast and mysterious than we can possibly comprehend with our current understanding. This isn't just about updating a textbook with a new chapter. It has the potential to fundamentally change our understanding of our place in the universe, our origins, and our destiny. The big question that hangs in the air, unanswered and tantalizing: did we get the beginning of the story wrong? Is it time to rewrite the first chapter of the universe? Deep within the vast expanse of space, a cosmic enigma has emerged, captivating scientists and challenging our fundamental understanding of the universe. Scientists have nicknamed this object Methuselah's star, a moniker that hints at its extraordinary age. But don't let the name fool you, though it's actually a whole galaxy, a massive collection of stars, gas, and dust bound together by gravity. And what's truly remarkable is that it's one of the oldest galaxies ever seen, a relic from the universe's infancy. The light we're seeing from Methuselah's star has embarked on an epic journey, traveling for an astounding 13.7 billion years to reach us here on Earth. That incredible travel time means we're observing the galaxy as it existed just 100 million years after the Big Bang, a time when the universe was still in its formative stages. To put that into perspective, that's like a newborn baby attempting to run a marathon just minutes after birth, an almost impossible feat. The real shock, however, isn't just its extreme age, but its surprisingly mature appearance. Methuselah's star doesn't look like the chaotic, clumpy galaxies we'd expect to see from that era. Instead, it looks remarkably mature, with a bright, well-defined core suggesting a concentration of stars at its center. And even more astonishing, there are hints of spiral arms, those iconic structures we typically associate with more evolved galaxies. It's not a small, fragmented collection of stars. It's massive and organized, a fully formed galaxy seemingly out of time. This level of structure and maturity is completely unexpected for such an early point in cosmic history. According to the prevailing Big Bang theory and our current understanding of galaxy formation, galaxies should have taken hundreds of millions, even billions of years to gradually coalesce and develop these features. Finding a well-formed galaxy so soon after the Big Bang is like pulling a perfectly decorated and frosted cake from the oven after only 1 minute of baking time. The scientific community has approached this discovery with meticulous care. The data from the James Webb Space Telescope has been checked and rechecked, analyzed from every conceivable angle, and the conclusion is clear. This isn't a fluke. This isn't a measurement error or an artifact of the data. Methuselah's star is a genuine cosmic outlier, a true anomaly in the early universe. Its existence is actively defying our current models of galaxy formation and cosmic evolution. It's not just a minor discrepancy or a small puzzle piece, it's a direct and profound challenge to our fundamental understanding of how galaxies, and indeed the universe itself, came to be. It forces us to reevaluate how order and complexity could have emerged so rapidly from the apparent chaos of the early universe. How did this happen? What unknown processes were at play? How could a galaxy, seemingly against all odds, form so quickly and develop such a mature structure in such a short amount of time? The answers to these questions could rewrite everything we thought we knew about cosmic history, potentially ushering in a new era of understanding. This groundbreaking discovery forces us to confront the very limits of our current theories, and to acknowledge the vastness of what we still don't know. With each new revelation, the universe just got a lot more fascinating, a lot more mysterious, and a lot more intriguing. Methuselah's star is a major problem for the standard model of cosmology, the Lambda CDM model. This model says the early universe was a dark, empty place, just hydrogen and helium gas, no stars or galaxies. Gravity was supposed to slowly pull gas together, forming the first stars and tiny galaxies over hundreds of millions of years. Our best simulations say it should take at least 400–500 million years for recognizable galaxies to form, and even then, they should be small and messy. But Methuselah's star is large and structured, appearing just 100 million years after the Big Bang. It's as if the universe skipped several hundred million years of construction. This suggests something is missing from our model. Is our understanding of gravity incomplete? Did the first stars form faster? Was the early universe less smooth than we thought? Maybe there were already dense seeds of matter right after the Big Bang. Each possibility would require a major revision of our fundamental theories. Methuselah's star isn't just an anomaly, it's a signpost pointing toward unknown physics. The universe may have secrets we've only just begun to uncover. When discoveries like Methuselah's star appear, scientists have to get creative. Maybe the Big Bang model needs a tune-up, or the early universe had different ingredients. Some theorists suggest massive black holes formed early, acting as anchors to build galaxies faster. Others revive the idea of a cyclic universe, a big bounce, where our universe inherited structures from a previous one. Even wilder, could this be evidence of a multiverse, or a relic from another cosmic cycle? And as unlikely as it sounds, some wonder if Methuselah's star could be artificial, a megastructure built by an ancient civilization. The data is so strange, no idea is off the table. Gazing into the vast expanse of space, we often wonder about the origins of everything. How can we possibly witness events that occurred billions of years ago? How do we see something so ancient, so far removed from our present reality? The answer lies in a remarkable feat of engineering and a fundamental property of the universe, the James Webb Space Telescope and the speed of light. These two elements combine to act as a time machine, allowing us to observe the cosmos as it existed in its infancy. Light, the fastest thing in the universe, takes time to travel across these immense cosmic distances. So, looking far out into space inherently means looking back in time. The light we observe from distant galaxies has been traveling for billions of years, carrying with it a snapshot of the universe's past. And to capture this faint, ancient light, we need a truly extraordinary instrument. Webb is the biggest, most powerful space telescope ever built, a testament to human ingenuity and our relentless pursuit of knowledge. At its heart lies a 21-foot gold-coated mirror, meticulously crafted to catch the faintest whispers of light from the most distant corners of the universe. The gold coating enhances its ability to reflect infrared light, a crucial aspect of its mission. It's like a giant bucket for photons, those tiny particles of light that have journeyed across vast stretches of space and time to reach us. Its sensitivity is so incredible that it's able to detect the heat of a bumblebee on the moon. This remarkable ability allows it to perceive the incredibly faint infrared signals from the early universe. Webb specializes in infrared light, a region of the electromagnetic spectrum invisible to the human eye. This is crucial because the universe's expansion stretches visible light into infrared as it travels across cosmic distances, a phenomenon known as redshift. This redshift effect means the farther away an object is, the more its light is shifted towards the red end of the spectrum, eventually becoming infrared. Therefore, to see the dawn of the universe, to witness the formation of the first galaxies, you need to look in infrared, and Webb is specifically built and optimized for that very purpose. Its infrared capabilities are unmatched by any other telescope. Its carefully chosen location, a million miles from Earth at the L2 Lagrange point, a gravitationally stable location in space, keeps it incredibly cold and stable, shielding it from the heat and light that could interfere with its sensitive infrared observations. This is achieved through its massive sun shield, which blocks out heat and light from the sun and Earth, creating a frigid environment for its instruments. This cold environment is vital, absolutely essential, for detecting the incredibly faint signals emanating from the most distant and ancient objects in the universe. Without it, groundbreaking discoveries like Methuselah's star, one of the oldest stars ever observed, would simply be impossible. In essence, Webb is our time machine, a portal to the past, letting us peer into the universe's earliest moments. A time when the first stars and galaxies were just beginning to form. It's revolutionizing our understanding of the cosmos, changing what we thought was possible to see, and pushing the boundaries of astronomical observation. The universe's deepest secrets, once locked away by distance and time, are finally within our reach, thanks to this incredible instrument. Finding Methuselah's star is a triumph of science and technology. Webb stares at empty sky for days, collecting faint photons from the most distant objects. Each tiny smudge in the image is a galaxy, but how far away are they? That's where spectroscopy comes in, splitting light into a spectrum to reveal chemical fingerprints. The pattern of absorption lines shifts toward red as the universe expands. Measuring this redshift tells us the galaxy's distance. Methuselah's star had the highest redshift ever recorded, placing it in the universe's first 100 million years. Webb's combination of deep imaging and detailed spectroscopy is revolutionary. Hubble gave us glimpses, but Webb can confirm the ages and distances of these extreme objects. It's this power to dissect ancient light that has turned a mysterious smudge into a universe-altering discovery. Methuselah's star isn't the end. It's the start of a new chapter in cosmic exploration. Scientists will point Webb back at it, dedicating precious time to gather more data. They'll analyze its spectrum for chemical composition and map its gas motions. The race is on to find more galaxies like it. Are they rare, or is the early universe full of them? If more are found, our theory of galaxy formation is fundamentally broken. This discovery will shape the future of space science, driving the design of even more powerful telescopes. A single, unexpected discovery can change the direction of an entire field. The journey to understand the universe has just begun. We're living in a new golden age of astronomy. The discovery of Methuselah's star marks a turning point. Now we can look back to the universe's beginning with our own eyes. We're in the era of observational cosmology, testing our biggest ideas with real data. Like Galileo and Hubble before, this discovery changes not just science but our perspective. The universe isn't obligated to fit our expectations. Its surprises are limitless. This is a story for everyone, touching on the deepest questions. Where did we come from? How did it all begin? The James Webb Space Telescope is a human endeavor, built by thousands, belonging to all of us. Its discoveries expand our knowledge and inspire us to wonder. Sometimes the universe shows us we haven't even been asking the right questions. The journey to understanding is just getting started. Methuselah's star reminds us, the more we learn, the more we realize how little we know. For every answer, a dozen new questions appear. We built Webb to find the first galaxies, and it may have found one that breaks our theories. This ancient galaxy has opened a Pandora's box of possibilities. The universe has thrown down a challenge, and scientists are eager to respond. As we keep searching, we're sure to find more surprises that stretch our minds and rewrite our textbooks. If a galaxy that shouldn't exist is just the beginning, what other impossible things are waiting for us out there in the dark?